So hello everyone, this is day 8 of writing 15 smart contracts in 15 days. Today we will be writing a very simple smart contract for leisure, right? In which the user can actually enter their transactions and just keep a log of their transactions, right? Writing this smart contract, we will be learning about custom data types in Solidity, right? So what is the need of this custom data types? Now, if we are making a contract for leisure, so we need to store the transactions, right? So we need a variable, a single variable to store the transactions, which have amount, timestamp, and the actual description of that transaction. So how can we do so? We are having structures in Solidity, which gives us the functionality to make custom data types, right? So what custom data types we will be using in this smart contract, we will be making a variable called transaction, which stores amount, timestamp, and the description, right? And we'll just simply map them using the wallet address, and the wallet address will be mapped with the salary, that is the actual transaction, and the time, right? So yeah, let's just quickly code this smart contract. So yeah, let's just go to the screen. I have a Hardhat project set it up over here. In case if you don't know how to set up the Hardhat project, check this documentation out. So yeah, let's make a file called leisure.solidity. Now I have to mention the license identifier, so SPTX. Then I have to give pragma solidity, and the version which I'm using is 0.8.28. Okay, so we'll go over here. Then I have to initialize the contract. So I'll use the contract keyword, contract, leisure, leisure. Now what I have to make is the actual custom variable that will be called transaction. So struct transaction, what we will be storing inside this, we will be storing amount, timestamp, and description. Right. So int 256 amount and string description and unsigned integer 256 timestamp. Right. And then what we need is a mapping. Yeah, I need a mapping with address and the transaction. Right. Okay, I'll call it as user transaction, user transactions. Right. So over here we have done this thing right over here. Okay. We have created a custom data type called transaction, which holds amount, description, and timestamp in it. Right. And we have a mapping with a wallet address. Let's say if I am having a wallet address, it will be the key. The wallet address will become the key, and all the transactions will be stored of this wallet address into this array called transactions. Right. Now, what we need is a function to actually add the transactions, right? Which will take the amount. So it's amount. Yeah, amount 256. I will take this suggestion. now, right? Then what it takes is the description, right? So string, I'll be using all data and description. And I will mark this as external. And yeah, I'll frame the function. Okay. Now what we need is to store the transaction of the user into this array or into this mapping. So what will we do? I'll use users transactions, and the user is message.sender, the one who is deploying the smart contract, dot push transactions dot push. It will be pushing all the transactions into this array, right? So yeah, we are having our add transactions SCTIONS add transactions function ready. Now we need a simple function called get all transaction. So function get transactions. Right. I have taken the suggestion directly because it's a pretty simple function. Right. So what it does is it uses this array, this transactions array. That's why we have used view over here, right? And it actually returns all the transaction of the users. Right. Yeah. Okay, so then we need a function to check the balance. Function check balance, or we can name it as get balance. Get balance. It won't take any, what we can say, it won't take any arguments. And external. What it returns is a integer, returns integer 256. I think it's giving correct suggestions. Mm, yeah, we will be initializing the balance with 0. Okay, balance 0. And transactions, memory, transactions. So we are using a new variable over here, right? Which is this variable, right? A structure over here, right? Transaction memory, and the name of this variable is transactions, user transactions message.sender, right? So it checks the balance for the on user using this array on the index of the address of message.sender, right? The index is message.sender, right? And then it just runs the for loop, and it actually increments the balance from 0, right? So yeah, this is pretty much it for the smart contract. Let's write a test script for this. So I'll make a file called pleasure test.js. Right now I need const ethers going to require hardhat const chai chai equals to require chai. Right. Oh, sorry, I need expect over here. Now, what I need is to describe leisure function, right? And now I need a before each case, for each, for each casing. Right now, what I have to do is first I have to declare the variable called leisure and a wallet address, right? Let owner, or let's say address one. Then what I have to do is connect the smart contract to this test script. Leisure equals to await ethers dot get contract factory leisure. Okay. Leisure dot deploy. Okay, I don't need to use the deployed function. And over here, I need a get signer function. So it will be address one and will be declared first. Leisure. Mhm. Ledger. Okay. So now we have pretty much everything for before each case. Let's write a test case for adding a transaction, right? So for that, what we need is write a it case. It adds uh, mm, Russia, right? It adds a new transaction, which is a async function. Async function. Okay. Now what we need is await leisure dot add transaction. What's the name of the function? It's add transaction. So I'll copy it from here. Add transactions. And what I need to mention is the amount that is 100. And I'll give it as a first transaction or selling, let's say. Okay. And let's add another transaction to the bonus and investment. Right, so what we have done is added up the transactions over here, right? And now what we need is to actually check the balance for this ledger. So now what we need is the ledger for this. So const transactions equals to await ledger dot get transactions. Okay, and here I will be logging it transaction. Okay, now let's just run this test script. NCX hard hat px hard hat s dot slash S leisure.js and yeah, over here we are having the whole leisure that is the first transaction is of 100, then 200, and then 300, and we are getting the description too. So yeah, this was the contract for maintaining the leisure, right? So yeah, see you tomorrow.